There we go. So, okay, so you have x to the 3/2 equals 7, and we want to use rules of actual algebra rather than superstition to solve this, okay? If you got the right superstition, it works because it coincides with rules of algebra, but just to be sure, here's what I'm going to do. I'm going to just say, okay, I've got x to the 3/2 equals 7. I'm going to raise both sides to the 2/3 power. And we might have done this once or twice, but okay, now why does this work? It's because x to the a raised to the b is x to the ab. And of course, I've asked you to test rules of this nature using small numbers. Okay? And if you use x equal 2, a equal 3, b equal 4, it's going to work out. Okay? Both sides are going to be equal. You can convince yourself of it. And there are other reasons it's equal. Okay? Because if you take x times x times x, a times, and then do b of those, you got a times b x's, and that's what this is. So, we've seen that, we've done it, but right now, that's a rule that allows us to solve this equation. You got to know this rule. And if you get the rules mixed up or forget them, you know how to test them using small numbers. Use some small numbers and see if it works. If it doesn't work, you got the wrong rule. Fix it. Okay? Best, of course, is you do a bunch of problems where you use the rules and get used to them. Okay, so you have this. So how does that apply here? Well, what is then x to the 3/2 to the 2/3? What's this rule say? Well, what's a and what's b?
3/2, 2/3.
3/2, 2/3. So x to the 3/2 to the 2/3 is x to the 3/2 times 2/3, x to the ab, x to the a times b, right? That equals 7 to the 2/3. Now you're pretty much done, because first 7 to 2/3 is something you can punch into your calculator, right? Okay? Or you can estimate it. It's just a little, I'd say 3.7 or 3.8, because I know 8 to the 2/3 is 4. Okay? But x to 2/3 times 3/2, what's 3/2 times 2/3? It's 1, right? It's 3 times 2, which is 6, divided by 2 times 3, which is 6. 6 over 6 is 1. I have to say that because people are shaking with fractions, but that's x to the 1 equals 7 to the 2/3. So x is the same as x to the 1. It's 7 to the 2/3. And I'm going to say that's, I'm going to go with 3.8. 3.7 might be. What'd you get?
3.66.
Ah, 3.66.
Well, I got 3.6.
That's okay, it's okay. Yeah. You know, you probably ought to have that thing serviced.
I know, I really should. That's beside the point.
Okay, so it's close to 3.7, but it's even less than 3.7, which means my estimate kind of sucked, but that's okay. Okay. Fair enough? And that's what I get for not visualizing the concavity of the graph. I didn't get quite enough sleep last night. I just didn't have the energy to do that. Wasn't that bad, you know, just a little edge loss there. Okay, so I apologize for my egregious error, but there it is, okay? It's really easy, right? If you got x to a power equals something, You raise both sides to the reciprocal power. Okay? Make sense? Okay. Okay, so I think we've kind of got that. I'm going to give you some problems to do with that. Okay? It's the same method for all of them. And the thing you have to do is don't just do it without thinking about what you're doing, because then you forget what you did when you do something else. Okay? So I'm probably, actually, to prevent a little of that, I'm probably going to intersperse that with some other things you know how to solve. You know, give you a few examples and then give you a few more problems where you got to use it sometimes, but other times use something else. So you get it in context.